Hello friends, have we met before? Well, you heard me before, but I think we have never met. I'm Atul Bhargava, who shared with you how to calculate the number of squares and rectangles in a figure like this. Do you remember? And it was me who made you feel like a superman when you were able to tell that there are exactly 63 crores 6 lakh 37,500 rectangles in a graph paper. In case you have missed any of these interesting tricks, just don't worry. You can always go back and learn them at our YouTube channel, Rise to Succeed. So friends, what do I have for you in store today? Well, today in this third tutorial of the 20-second challenge series, we will discuss yet another question that is frequently asked in competitive exams. And that question is, how to count the number of triangles in a figure like this, and that too in less than 20 seconds. So, what are we waiting for? Let's start the fun. I'll first take up a medium level question to explain how this works. The question is, how many triangles are there in this 4 centimeter triangle that you are seeing on your screens right now? To apply the shortcut, first you'll have to learn a very simple series. This series starts with 1. Now add 2 to it and you get 3. Now add 3 to it and you get 6. Now add 4 to this 6 and you get 10. Now add 5 to this 10 and you get 15. The series can keep continuing like this. Most of you would have got the pattern in the series, but I'll still explain it for your convenience once. We will always start the series with 1 and add 2 to it. Then we will keep adding one higher number than we previously added to get the series. Now let's see the shortcut using this series. But first tell me, what's the size of this triangle? Yes, it's 4 centimeter. So we write down numbers 1 to 4. Now form 2 columns here like this. In the first column, starting from the bottom, and I repeat, starting from the bottom, start writing the series that we have just learned. So 1 comes here, add 2 to it, so 3 comes here, add 3 to it, so 6 comes here, and lastly add 4 to it, so 10 comes here. We can't go any further, so we stop here. Now starting from the top, and I repeat again, starting from the top this time, take alternate numbers from the first column and write them in the second column. That is, you will leave 10 and take 6 and write it here. And then you will leave 3 and take 1 and write it here. Now just add all these numbers. 10 plus 6 plus 3 plus 1 plus 6 plus 1 and you get 27. And that's your answer. So wasn't that easy? And is it doable in less than 20 seconds? That's the very magic of this 20-second challenge series, friends. Before taking up a bigger question to apply this shortcut to, let's first actually count and see whether we have got the correct answer or not. This verification will also help you in answering another important variety of question which is frequently asked in competitive exams. But first, can you tell me how many different sizes of triangles can you see in this figure? Yes, there are 4 different sizes of triangles. We have 1 centimeter triangles like this one, 2 centimeter triangles like this one, 3 centimeter triangles like this one, and 4 centimeter triangles like this one. Moreover, these 4 sizes of triangles can be further broken down into 2 categories. First, triangles like this. We will call them upward facing triangles because their base is at the bottom and vertex is at the top. And the second category, like this one, we will call them downward facing triangles because their base is on top and vertex is at the bottom. Now our aim is to systematically count triangles under all these combinations. Let's first count the number of upward facing 1 centimeter triangles, and that's easy to count. As you can see, there are 10 such triangles. So we write 10 here, and all the remaining 1 centimeter triangles are downward facing triangles, which are 6 in number. So we write 6 here. Now we move on to counting the number of 2 centimeter triangles. Please look very carefully. We'll take it layer by layer, starting from the first layer so that we don't miss out on any triangle. On layer 1, we have triangle number 1, triangle number 2 and triangle number 3. On layer 2, we have triangle number 4 and triangle number 5. And on layer 3, we have triangle number 6. So we get a total of 6 upward facing 2 centimeter triangles. We write 6 at its correct position. What about downward facing 2 centimeter triangles? Yes, you only have one such triangle. Hey, I know you are comparing both these green boxes and saying that we are on the right track. But just hold on for a few more seconds, friends. Let's first finish this up and then we will compare. Let's count the number of up-facing 3 centimeter triangles. That's triangle number 1, triangle number 2 and triangle number 3. So we have 3 up-facing 3 centimeter triangles. The remaining part is pretty easy. There are no 3 centimeter downward facing triangles, only one upward facing 4 centimeter triangle and no downward facing 4 centimeter triangles. Now you know what to do. Just add these 6 numbers and you'll get 27, which is pretty obvious because both the green boxes, as you can see, are exactly the same. Now let's get back to our 20-second short trick and understand it even more properly. The first column gave us nothing but the number of upward facing triangles of size 1, 2, 3 and 4 centimeter respectively. And the second column, as you can see, gave us the number of downward facing triangles of size 1, 2, 3 and 4 centimeter respectively. So now if the examiner asks you to find only the number of 2 centimeter triangles, then your answer will be 6 plus 1, that is 7. Now let's quickly move on to a much bigger question. Such big questions are generally not asked in competitive exams, but we are a champion, right? So anyway, let's do it in less than 20 seconds. The question is, find the number of triangles in this 7 centimeter triangle. Well, you can actually pause the video and try it out. Right, so the correct answer is yes, it's 118. Let's solve it quick and fast. This is a 7 centimeter triangle, so we write numbers 1 to 7. Then, starting from the bottom, we write our series like this: 1, 3, 6, 10. Now adding 5, we get 15. Adding 6, we get 21. And adding 7, we get 28. For the second part, starting from the top, we take the alternate numbers. That is, we take 21, 10 and 3 and write them in the nearby column. Lastly, we add them all up and get our answer. So with this, I'm done for the day. I'll catch up with you again in the next tutorial, which will be on counting the number of triangles in this kind of a figure. Until then, subscribe to our channel if you haven't done till now, so that you don't miss out on any of these tutorials. And you can also check out my book Campus 500, whose Amazon link I've shared below in the description space. Thank you and enjoy your day.